Welcome to another Fast Tech video. In this one, I'm going to be addressing some comments that I got on my PS3 60GB and 80GB disassembly and repair videos. I got a lot of people commenting, stating that yellow light of death issues are caused by the NEC/TOKIN capacitors that are located right under the GPU and CPU chips on the PlayStation 3 systems. I am going to be debunking that claim today, as it has been disproven by many different videos and articles that have been written regarding this issue. This video that we're going to be playing today is from a channel called RIP Felix, and he did a tremendous job of breaking this down. Let's get into it.
Another popular idea is that the NEC token bulk filtering capacitors are defective, that to prevent them from causing the yellow light of death, you should recap using tantalum polymer decoupling capacitors. However, the tokens are superior in almost every way compared to the caps you will be replacing them with. When you replace the tokens, you need to be careful about selecting.
That's true, guys. A lot of people underestimate manufacturers. Sony has spent years and years researching, testing those capacitors with that particular system, with that heat specification, with that case on. They do all that testing for a reason. They know what they're doing, and that's not saying that they don't make any mistakes. Otherwise, I wouldn't be in the business that I'm in. But they do. They have tested these capacitors on these systems, and I'll tell you another reason why people believe the issue is caused by these NEC token capacitors that are being replaced in this video. When you remove these capacitors, you have to heat this area on the board with a hot air station, or worst case, a heat gun. When you heat this area, what also gets heated is the CPU and GPU, which is right above it. You heat up the solder connections on the CPU GPU chips, and in most cases the soldering is the cause of the issue, or maybe even the chips themselves in some rare cases. And by inadvertently heating up those components, you end up fixing the problem as you're needlessly replacing these NEC token capacitors. Now, I'm not saying that you might not find a system where these capacitors have failed. That's completely possible. But they do not usually fail. That's not usually the failure point. We started this business doing Xbox 360 red light repairs and then PS3 yellow light of death repairs. We have fixed tons of systems not working on we were not working on the token capacitors at all. We've never, I think maybe there was 2 instances where we replaced these way back in the day. But from my experience, from the yellow light of death systems that we saw and we fixed, a reflow or a reball would fix the issue, not replacing the capacitors.
Capacitors that meet the token specifications, combined capacitance, ESR, and voltage rating. And because the tantalum polymer caps don't attenuate high-frequency noise as well, you may want to consider adding an array of multi-layered ceramic capacitors to knock the high-frequency noise down a bit. I don't want to get too far into the electrical engineering side because I already wrote an exhausting series of posts detailing it and made a replacement designed to make soldering easier. The point is that the NEC tokens are better, and you shouldn't want to replace them unless you have to. They can last a long time in a properly maintained console, so removing them should not be considered preventative maintenance. I'm starting to get a bit ahead of myself though. Let's back up a bit. You need to understand what causes the yellow light of death, and that was a hot topic for a long time. In my opinion, the best video on YouTube about this issue is the video done by Displaced Gamers.
When the TV series mentioned earlier elected to use their special oven to reflow the board, they didn't isolate a problem. They actually changed a lot of variables by applying extreme temperatures across the entire board. This doesn't specifically reflow the GPU and CPU solder balls, it reflows pretty much everything. A second method people turn to is reballing. It is as simple as it sounds. The board is heated up in a localized area to free the solder balls, the processor and old solder balls are removed, and then the processor is reattached to the board using fresh solder balls, either lead-free once again or with lead this time. Both a reflow and a reball still involve playing a wild card, heat. Whether the entire board is heated up or just the area where the processor is mounted, the heat is naturally going to affect other things.
That's true. You inadvertently heat other components when you do a reflow or reball. He's absolutely right on that.
Especially cranked up to reflow temperatures for lead-free solder.
And yet even that one is misleading. It seems to suggest that BGA defects are not the real issue, but that's not what he's saying. He's just saying we shouldn't assume they are.
I want to make it clear that I'm not saying a reball isn't a potential fix for a PS3 yellow light of death. My point is that it isn't the solution, and that we as a community should adopt less of a tunnel vision approach when it comes to diagnosing and repairing consoles.
And he's right. In fact, he did a very good job of presenting the information objectively at a time when everybody was jumping on the tantalum bandwagon. But it skewed towards the better narrative, which is hard to avoid.
So is that it? Regardless of the specifics, we can assume the problem is still most likely in or under the chip somewhere? No, it gets better. Enter NEC TOKIN and their special capacitors.
The tutorial that started this behemoth thread also started a popular misconception.
Yep.
One that currently has a death grip on the gaming community.
Yep.
So, what about...
And I can't... People keep commenting on my videos. You gotta replace the capacitors. You gotta replace the capacitors. Guys, I don't want to hear that again. The capacitors, in 99% of the cases, are not the issue. I'll say it one more time.
These capacitors? Well, they were developed in the early mid-2000s and apparently have a rather short lifespan. Toshiba laptop users discovered this the hard way when their computers wouldn't start.
I need to address some misconceptions about this laptop before we continue, because it's often cited as an example of defective NEC tokens. If you look closely, you can see that the tokens are directly underneath the processor. You can see its backplate there. That's the best place for them electrically, because the closer you place decoupling capacitors to the processor, the better their effect.
Yep.
But it's also the worst place for heat. A capacitor's life expectancy is calculated based on how hot it runs. The closer to the processor it gets, the shorter its life. And these are as close as you can get. By comparison, look at where Sony placed them. They are adjacent to the processor and separated by thermal vias, which help to prevent heat from the processor from traveling through the motherboard to the capacitors. A laptop is a very hot, enclosed space. If they operate up to 85 degrees Celsius, which is very possible since the laptop's processor often runs near their 100 degrees Celsius max, at that temp, they would only last between 4,000 and 10,000 hours. Or 166 to 416 24-hour days. If you used a laptop for 8 hours a day, every day, it would take 1 to 3 years to die. I think we can agree that wouldn't be acceptable. However, Sony placed the tokens in a much better spot, which ran cooler. From my own tests, in a well-ventilated console and at a room temperature of 20 degrees Celsius, or 68 degrees Fahrenheit, they ran 65 degrees.
I wouldn't say it's the ideal place to put them, because that area also does get hot. So it's not an ideal area to put them in. They could have been placed better, but again, they have to be placed closer to the processors.
Once the console was up to temp. Using Comet's equation for calculating capacitor life based on operating temperature, these should last 667 days in the PS3, at least. That's assuming the worst case scenario, that they perform like an electrolytic cap. If you played 8 hours a day, 7 days a week, the caps could fail in 5.5 years. But according to BGR.com, the average gamer in the US only spends 22 hours per week playing games. So that would mean the average gamer's PS3 could last 29 years with its original tokens, if well maintained. And let's say it wasn't well maintained, full of dust, and the tokens operated at 85 degrees Celsius. In that case, the average gamer's PS3 could...
That's why it's important to clean out your system, and check out our video. We show you how to thoroughly clean pretty much all PS3 systems at this point. We've done the A01, G01, Slim, Super Slim. It's very, very important to keep your console running clean and replace the thermal paste every 3-4 years. Every 2 years if you can.
Die in
depending on how much you play.
Half years. So yeah, it's important to keep your console dust-free and out of enclosed spaces like a cabinet. Or in other words, there was nothing wrong with the tokens. They performed according to their stated specification. Engineers need to take that into consideration when designing the cooling solution. Toshiba apparently did not get the memo.
The solution is to remove the specialized capacitor and work in 4 tantalum capacitors in its place, making sure the replacement's capacitance total meets or exceeds the original cap and that the ESR remains just as low. This restores the laptop to working order. It seems to be a very common problem and repair with the Toshiba A300. And of course, the PlayStation 3 uses 8 of these same capacitors, 4 on each side of the motherboard, 2 pairs for each processor. If these caps can't help maintain proper voltage for the CPU or GPU, guess what? Yellow light of death. Some capacitor types can come back to life and do their job after adding, you guessed it, heat. I can't say for certain if these particular capacitors could temporarily return to meeting the PS3's needs if they are blasted with a bit of heat for diagnostic purposes, but I can say that certain guides...
Again, the problem with that is if you heat up only these capacitors, you're also going to end up heating the CPU and GPU chips, which are right above it, thus heating up the solder underneath them, thus doing a reflow essentially on them. And that is what fixes the issue in most cases, at least temporarily with a reflow. A reball is much more permanent, but you could still have issues after a reball.
They are blasted with a bit of heat for diagnostic purposes, but I can say that certain guides found on the net actually recommend using a heat gun on these chips, as they call them, as part of PS3 repair.
Is the dark side stronger?
No. But busier, more seductive. Look, you must complete the training.
I can't keep the vision out of my head. They're my friends. I gotta help them.
You must not go.
But Han and Leia will die if I don't.
You don't know that. Even Yoda cannot see that fate.
But I can help them. I feel the Force.
But you cannot control it. This is a dangerous time for you, when you will be tempted by the dark side.
Repair.
Yes. To Obi-Wan you listen. The cave. Remember your failure at the cave.
But I've learned so much since then. Master Yoda, I promise to return and finish what I've begun. You have my word.
POST stands for Power On Sequence Testing.
Okay, so that's the end of the segment that covers the NEC token capacitors. Make sure you guys follow this channel. He does some good videos. RIP Felix, great job on this video. He had a few hundred subscribers when I first saw this video, and now he's at 6,500. So good job. And I hope that ends the NEC token comments on the channel. I hope this was an educational video for all of you who seem to insist and are stuck on the idea that the yellow light of death is caused by defective NEC token capacitors. And I'll tell you, in my 10 or 15 years of overseeing PlayStation 3 repairs, and we started off where I was doing them all by myself, I'll tell you personally that in almost all of the cases, doing a reflow on the CPU and GPU chip or a reball is what fixed the problem. Make sure to smash the like button, subscribe to the channel, and I know this is a little bit unusual compared to the other videos that I do, which are mostly tutorials, but if you'd like to see more videos like this, make sure to leave a comment in the comment section and share it with your friends. This is Shiroz from Fast Tech, and I'll see you in the next one.